All, my name is Rahman and welcome back to my YouTube channel. So guys, in this video I am going to continue to discuss the fundamentals of support vector machine. So where we left off in the last video, we were solving an equation. If you remember, where we were solving an equation where we have width equals to the x sub plus vector x plus minus vector x minus equals to 0, something like that, right? So guys, you are having that equation, and guys, we were solving this also. And guys, in this video I'm going to also talk about the constraint optimization with the support vector machine. Now guys, if you remember, in the last video we were solving the equation like we have the width equals to x plus minus x minus into vector w by w norm, right? So guys, at that time what we want to do is we want to maximize the width b. So guys, I'm going to continue to solve those equations right now in this video. So let's go ahead and get started. Now guys, where we left off in the last video, we were solving this equation as I said before, which is width equals to x sub vector x sub plus minus vector x sub minus into vector w by norm w. Now guys, as I said you, what I want to do is I want to maximize this width and minimize this text, right? Now guys, if you notice here, we got the x plus and the x minus in there. Now these two are the hyperplanes we are referencing and trying to maximize the distance between them. Guys, and one more thing we have is there are no b's here right now, right? So we are saying that we don't have any b. So if you remember some videos, one video before, they were having an equation where you have something like y sub I into xi vector x sub I into w plus b. So at that time we're having b, but guys, if you see here, we don't have any b, right? That's nice. Now guys, what about this x plus minus x minus, right? We have this x plus and x minus. What are these, right? So guys, let's recall our equation where we had the y sub I and y sub I into x sub I plus w sub I. So sorry, y sub I into vector x sub I vector w plus b minus 1 equals to 0. So here I didn't give vector here. Anyhow, let's keep like this one. Now which is equals to 0. But guys, here if you see, we have the b, right? At the time, from the time we are saying that we don't have any b. Now guys, at the time, after some time we are going to solve this b also. Anyway, now guys, what I'm going to do is I'm going to plug in the equations to do the algebra, and we get the x plus and x minus. So guys, as you can see here, we have the width. Now guys, what if I find the value of x plus with the algebra? Alright guys, at the time if you do something like that, then guys we are going to get 1 plus b 1 minus b, something like that. Okay, 1 minus, we are going to get something like 1 minus b. But guys, if you do for the x minus, then we are going to get for the x plus 1 plus b, right? Now guys, if we do this for the whole equation, right, if we work the algebra with the following equation, then the entire equation comes down to being 2, right? Something like 2 by vector w norm, something like this. Then we are going to get the output around 2 by vector w, something like that. Now, so guys, if you use here the 2 by w vector w, sorry, I should give something like this. At the time I was not getting. So anyway guys, if we give something like width equals to 2 by vector w, something like this, then now guys, what I want to do is let's see what we are going to get if we give something like this. Now guys, what we want to do is we want to maximize the width and we want to minimize the vector magnitude of vector w, right? So guys, we want to minimize this one and we want to maximize this width, right? So guys, for doing, we can also give something like 1 by 2 and it should be something like vector magnitude of vector w, whole square. So guys, we can also do in this way for doing, and that is, if you see 1 by 2 into, we are not giving beside this one or beside this 2, I am giving this beside this one, and 1 by 2 into magnitude of vector w square. Guys, we can also do this in this way. Now guys, here we have a question that why we are giving something like 1 by 2 into where, and then we are getting the magnitude of vector w square, right? Because guys, what I want to do is I want to 1 by 1 half this, okay? So guys, this is not 1 by 2, this is 1 half of the vector w. This is 1 half of the magnitude of the vector W. So guys, this concept is a little bit confusing, but guys, if you understand it properly, then it's going to be pretty much easy. Now, so guys, what you want to do is you want to minimize the one half of the magnitude of vector W square with the constraint to our support vectors which we have defined as being something like, what to say, y sub I into, I'm going to give something like x sub I, okay, x sub I, x sub vector x sub I, then let's use as W plus B minus 1. Okay, so guys, this is our optimization of constraint right now. So guys, this is how we have defined. So with the constraint or to our support vectors which we have defined as being something like y sub I into x sub I into W plus B minus 1. Now, so guys, here what I'm going to do is I'm going to bring here the concept of Lagrangian. Guys, Lagrangian, first of all, I'm going to talk about what is Lagrangian in support vector machine. So guys, Lagrangian is also defined as L. So the exact spelling of Lagrangian is Lagrangian. Okay. Now guys, so guys, solving for the gradient of the Lagrangian, finding the points with the gradient of f and g are parallels. So guys, here I use the f and g for just an example. So guys, as I said you what is Lagrangian in support vector machine. Now guys, I'm going to solve this equation with the Lagrangian. Now guys, as you can see here, we have the L. As I said you, Lagrangian is going to be defined as L here. Okay. Now we have the L into WB, we have the WB. So if you remember guys, we are having something like y sub I into x sub I W plus B. So guys, here I use that W and that B, which is equals to half of the vector magnitude of vector square here, and then minus, I have done the minus, and the sum of alpha sub I have done, and then with that what I have brought here is, here I brought that, if you remember, we have a equation known as y sub I into x sub I W plus B, right, minus 1. So guys, here is what I have done right now. So I brought something like L into W plus B equals to 1 by 2. Now guys, we have a question that what we want to do here is that we want the W to minimize and want the B to maximize. Now, so guys, I said you W and we want to maximize the B and minimize the W. Now guys, here we have a question that what is B, right? Now guys, if you see here in the hyperplane, we have the W into X, right? WX plus B. So guys, if you remember some videos before, we have used a formula known as, in the regression theory, around some those videos, we have a formula known as mx plus b. So guys, it looks something like this, wx plus b. So guys, this is just a simple hyperplane equation for the hyperplane, and that is wx plus b. Now, so guys, coming back to our Lagrangian equation here that you are seeing is that here we have the L and all of these things, right? So guys, as I said, we want to minimize the w and maximize the b, right? Now guys, what we have to do is we have to differentiate the L. We have to differentiate the L with the respect to W, right? So with the respect to W, and then we have to, here they are differentiating with the L with the differentiate to W, and then we are going to differentiate the L again with the B, right? Now differentiate L again with respect to B. Okay, now so guys, here with this one we are going to get a new type, this one only, but in another way of it. This now guys, we are going to get an equation which will be in another form, but it will be this one only. Now so guys, some of the time we were having two options, one, and first is we have to differentiate the L with the W, and then we got the equation for that also, and that is, here you can see dl by dw equals to W. Okay, and then we have W equals to sum of alpha sub I y sub I into x sub I, and then for the dl we have, as you can see here, for the dl by db, which is differentiating the L with the B. So we have the sum, then we have the alpha sub I, y sub I equals to 0. Now so guys, as you can see here on the screen, we have the, as I said, we are going to get the same equation but in another form, and that is it. So guys, we have the L equals to sum of I sub I, then we have the alpha sub I minus 1 by 2, then we have the sub sum of two sub i's, and that is I and j, and then we have the alpha sub I and alpha sub j. With that we have the y sub I and we have the y sub a into y sub j into vector x sub I into vector x sub j. Now guys, here we have a problem, right? So guys, if you see here in this equation, in this calculation, here we have alpha sub I and alpha sub j. So guys, the problem is that we have these things and these are the this is also known as the quadratic problem. So guys, it's little bit confusing for us right now. So guys, here we are getting it's not looking good because of these alpha squared, right? Now guys, we are looking at a quadratic programming problem here. So guys, this is known as the quadratic programming problem. Now, so guys, from the starting we have our goal is to maximize the W, right? Vector W. Now guys, here we have a question that is it a constraint optimization or a constraint optimization if massive field true or not? Yeah, we have a question, right? Yes guys, we have that, and we have another question, and that is we have another way for doing this one, right? Now guys, we have another way. There are other also ways. The SVM's optimization problem is a convex problem here right now, where the convex shape is the magnitude of vector W. Now, so guys, as I said here before, that we have a problem, and that is we have another problem, and that is the convex problem, where the convex shape is the magnitude of the vector W. So guys, to solve this, the objective of this complex convex problem is to find the minimum magnitude of vector W, right? So guys, so for solving this, there is a one way. So guys, that one way is to solve convex problem is by stepping down, by going to the previous steps. Now guys, as you can see here on the screen, here we have this convex shape line, which is the magnitude of W. And guys, what we are doing here is we are seeking the magnitude of W to minimize as best as I can. For example, we have the center line here. Let's say we have a line here, and we are seeking the magnitude of the vector W to go down, right? So from here to here. Now guys, for example, if I show you with an example here, if I keep here a ball, something like this, a ball is available here. Then if I drop it from here to here, then what it's going to do is it's going to move from here until it's going to come till here, right? And then again it's going to come from here to here, again it's going to come like this. At the end of it, it's going to stay in the middle point. So guys, that's the thing that you want here. So guys, what we are seeing is we want to minimize the magnitude of W. Now, so guys, instead of these balls, dropping these balls, what we are doing is we are taking the vectors of W, where we are plugging the equation, and that is y sub I into x sub I into W plus V. If I show you here, the equation is y sub I, and then in the brackets, what we are doing is we are inputting the x sub I with the W. Let's say this is the point, and we have the W and then we are doing it plus B, and we are keeping it as a greater than or equal to 1, right? So guys, instead of balls, rather than balls, we are just taking here the vectors of W, magnitude of vectors of W, where we are plugging here the equation where we have the y sub I into x sub I into W plus B greater than or equal to 1. So right now guys, we don't have any problem for the minus and the plus, because if I show you with another example here, by let's say what's the shape, we have another question, and that is what is the shape of vector W, right? Now if I give here something like, let's do it, vector W, okay, and we are giving something like this. Right now guys, let's assume it the shape of the vector W is 1 by 2, 1 into 2. Now guys, let's give it something like, in the brackets I'm going to give it 5, 3. Okay, now guys, here what we have is, if I show you the what is 5, 3 here, if I show you, then it's going to be in the root, right? Now it's going to be something here. It's going to be something like this in the brackets. Here if I give 5 square plus 3 square, then here we have the 5 square, it's going to be 34, right? Let's give it as 34, because 5 into 5 is 25, and 3 into 3 is 9, right? 25 plus 9 is 34, right? Now guys, here I'm going to give it 34. We are getting the output is 4 right now. But guys, what if we give here the minus 5? Let's see that also. Minus 5, 3. Okay. Now guys, we have the 5 square. Instead of 5 square, let's give it as minus 5 square. Right. We have the 5 into 5. Let's multiply the 5 into 5, and that is 25. And guys, we have to multiply into minus. Right. Minus into minus, we are going to get to the plus. Right. We are going to get again 25 plus 3 and 25 plus 9. Still, we are going to get something like 34, right? So guys, as I said before, right now we are not getting any problem for the minus and the plus. So because here we are getting the same results if I am giving the same thing here. If I give the minus 3 also, then we are not going to get any change here, because it's going to square here and then it's going to get the same output, and that is the root 34. Now, so guys, we don't have any problem if we are having the plus or negative or positive. But guys, what if we have the hyperplane equation? Like for example, let's say we have the x sub I into w. Let's keep it as w, and then plus b, something like this, is equals to something, anything. Okay. Now guys, what if we give the value of x sub I 1, 2? Let's give it as 1, 2, right? 1, 2, and for the w, I'm going to make some dot for that one. Let's assume it as a dot. Okay. Okay. Now guys, here for the w, I'm going to use the same example, and that is 5, 3. 5, 3. Then guys, here we are going to get a big difference here, right? Now, so guys, coming back to our example of the bowl here, let's see. Now guys, I don't want, wait. Now guys, for example, if I take here a smaller step here, something like this. If I give from here, then here, I'm going to give something like this. Sorry. So something like this. I'm going to take here these smaller steps like this, then it's going to become till here, and it's going to end up here, right? Now guys, as I said before, we are forcing this vector w, we are forcing the magnitude of w to be minimized, right? So guys, it's going to come something like this. Then guys, what if we take here the larger step, something like this? If I take one, let's choose another color, because we are going to get confused. If I give something like this, and then it's going to start from here, and then it's going to come something around here, and then guys, here we are going to get another one, right? So guys, this is how it's going to work, something like this, right? So guys, if we have to get into the smaller steps if we give up, right? So guys, you can see this. If you see here, we have a middle point in the blue color that you are seeing here. This is known as the minimum or min. Let's call it as the min, or guys, it is also called as the global minimum. Okay, so guys, this is also called as the global minimum, or you could say global min in the short form. Now guys, when you find the perfect bottom, right, when you find the perfect bottom of the convex shape, then guys, we are going to call it as a global minimum, as I said right now. So guys, I have a question that why is this convex problem nice, right? So guys, the reason why is the convex problem is very nice is the reason why we use this step method to find the bottom, right? Like something like this, we use like starting from here, and then it's going to come up till here. Or guys, if you see another way I can use here is, let's use this. Now from here it came like this, right? But I stopped these lines here. Then I can also continue something like this, very small till here, right? Now guys, imagine if rather than a perfect convex shape, you would have another type of shape, and that is something like this. If you see, we have something like this shape, right? Now guys, while taking these steps starting from the left, if I take these steps, I'm going to take the steps from here, because from the time I'm taking here. Now if I take the steps from here, something like this, and this, if I take the steps from here, then you might detect that you are going back up. So you go back and settle in what is known as local minimum. So guys, while starting from here and while you are going back, then this is known as local minimum. So guys, that's known as the main center point is known as the global minimum, and this is known as the local minimum. So let's give it as local So anyway guys, again though we are working with a nice convex problem here. So guys, this is known as the local minimum. And guys, here right now again we are going to work with the convex problem. So guys, right now we don't have to do exactly worry about that right now. Now here my goal is to give us a vector and slowly step down the magnitude of the vector, which just means the lowering the absolute value of the data inside our vector. So guys, for example, let's say for each vector, let's say that 10. Okay, for each vector, let's say we have the 10 by 10. Okay, for each vector we have the 10 by 10, and we will transform that vector by the following, by the 1 minus 1 minus 1 comma 1 here, and then by the y again minus 1 comma 1. Again we are going to do something like this, and again what we are going to do is we are going to do in a different way, that is minus 1 comma minus 1 again. And guys, again we have different type, and let's choose it here again, and that is minus, sorry, it is 1 comma minus 1. Okay, so guys, we are going to do these things in this way, right? First of all, we have the minus 1 comma 1, we have the minus 1 comma 1 again. Sorry, first one is 1 comma 1. Okay, if I show you, these two are same. I have done a mistake here. Now we have the 1 comma 1, and they have the minus 1 comma 1 minus 1 comma minus 1, and we have the 1 comma minus 1. Okay, so guys, this will give us the all of the variances of that vector that we need to check for. Okay, despite them all having the same magnitude. So anyway guys, that's all for this video. I hope you liked this video, enjoyed watching this video, and in the next tutorial I'm going to implement these things with I'm going to create the SVM from the scratch and I'm going to implement this with Python. So anyway guys, that's all for this video. I hope you liked this video, enjoyed watching this video, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye bye.